In example 1, we're going to solve these linear systems by using linear combination. So what we're looking for is we're looking for one term to be exactly opposite the other term. That's not the case right away, although these are lined up vertically, which is good. To change a 5 into a 3, or the opposite of 3, or vice versa, would be a little troublesome. I think it's going to be easier in this case just to multiply the entire bottom equation by -3. If we do that, we'll have -3 times 2x, or -6x, which is exactly the opposite of 6x. So let me write that first equation down for you. And then I'll bring the second one down after we've done the multiplication. So that's this one. Now we can add these two up. So we've got 4y, -4y, is equal to 4, divided by -4, and y is -1. To find x, we can use either equation. Let's just use the first one. And we'll substitute y in. And we'll add 5 to each side. And divide by 6. And we find x to be 4. Normal to write the solution to this as an ordered pair, so we would write 4, -1. I want to make sure that this is actually the solution, so we can do a little check. Let's use the equation we didn't use last, so this one we just used here. This one we didn't though, so we'll take 2, multiply it by 4, add 3 times -1, and we should get 5. So we have 8 minus 3 is equal to 5, and that's a true statement. For part B, we have a similar setup to part A, but in this case, it's not going to be easy to change either a 4 to a -3 or a 5 to a 2, or the opposite of those. What we want to do in this case is we want to look at any term except for the constants, just either the 4x or the 5y, and or the -3x and the 2y here, just the x's, or just the y's. And let's take a look at the first set here actually. Let's do the 4x and the -3x. So if we want to multiply this equation by a good number, we can look at the other one's coefficient. I'm going to multiply this just by 3. If I multiply it by -3, I would get a negative value, and I want these to be opposite. Also, just looking at the x's, we can multiply this equation by 4. Notice the number is the same, 3 and 4, except I want this one to be positive and this one to stay negative. So if we do that, multiplication here with the first equation, we've got 12x plus 15y is equal to 105. The second one is going to be -12x plus 8y is equal to -36. We'll add these two together. We get 23y here. And on this side, we're going to get 69. So we'll divide by 23. And we think y here will be 3. To solve for x, you can pick either equation. I'll just arbitrarily choose the last one. I think we used the first one here previously. So we'll do 2 times 3 is equal to -9. We'll subtract 6 from each side and divide by -3, and we find x to be 5. So the solution to this one is 5, 3. We do want to check it though. So to check it, we're going to choose the other equation. We'll just substitute 5 and 3 in the appropriate places, and hopefully we get 35. So we've got 20 plus 15 is equal to 35, and that is a true statement. So that one's good. Let's work with C now. In C, it's easiest to focus on the x terms. The y terms here would be a little difficult. We could do the same thing we did kind of up here. But what I'd like to do is if I could, just multiply one of these. So all I need to do is multiply this one by 3, and I'm going to get negative 6x here, and then I'll be able to do that linear combination and eliminate one of the variables. So we've got negative 6x plus 9y is equal to negative 15. We'll add those up. Negative 2y, 9y is 7y. Got negative 14, so we'll divide by 7, and y is negative 2. To find x, all we need to do is use either equation. We'll just choose the first one and substitute that negative 2 in for y. Carry that over here to the right. We'll subtract 4, so 6x is equal to negative 3. And divide by 6, and we get x to be negative 1/2. So the solution to this one is negative 1/2, 2, or at least we think so. Let's just double check that. So the equation we used last was the first one, so let's use the second one to check. So negative 1/2 will go in for x, 2 will go in for y, and hopefully we get negative 5. Oops, that's going to be a 1. Plus 6 equals negative 5. 7 equals negative 5. We might have made a mistake somewhere. Oh, it's negative 2. Whoops, there's a mistake. So it's 3 times negative 2, which is negative 6, and 1 minus 6 is negative 5. So this one does check. With this piece right here, the 2 and the 3 don't have a common factor, but 5 and 10 do. And so we're going to be able to work with those a little bit easier. Oops, let me erase that, sorry. We're going to want to multiply this top equation by negative 2. If we do that, we're going to have negative 2 times 5y, which is negative 10y, and we'll be able to add those together. So I'll write that down first. There's your first equation. We'll just bring that second one right down. Now it's time to add those up. So we've got negative x here, and then negative 9. Divide by negative 1, and x is 9. To solve for y, we can choose either equation. Let's just choose the first one. So it'll be 2 times 9 plus 5y is equal to 3. 18 plus 5y is equal to 3. Subtract 18. Divide by 5. And we find y to be negative 3. So the solution to this one is 9, negative 3. We'll just check that real quick. As we found out in the previous example, sometimes you make a mistake. And the only way to find that really is to check it. So we'll choose the equation we didn't use previously, which is this one. And we'll see if this works. So we've got 27 minus 30 is equal to negative 3. And negative 3 is equal to negative 3.